Now finding the equation of the perpendicular bisector is not difficult. All you need to do is to, first of all, find a gradient. If you know the gradient of the straight line, and if you know a point on the straight line, you can use the formula y minus y1 equals to gradient x minus x1. Now finding the x1 and y1 is not difficult. All you need to do is to use your midpoint theorem. You can use your midpoint theorem, okay, using the points 0, 0 and 3, 3 to find this point. Now once you know that point, then the next thing you need to do is to find the gradient. Now the gradient of the perpendicular bisector, okay, remember it's a perpendicular bisector, so it's also a line that is going to be perpendicular to the line joining 0, 3, 3. So that's how you can work out the gradient. Now you notice everything is printed out nicely for you. The midpoint of the segment, okay, or perpendicular bisector is 3 plus 0 over 2, 3 plus 0 over 2. So you get 3 over 2, 3 over 2. Then you look for the gradient of the line joining 0, 0 and 3, 3, and then you get 1. So the gradient of the perpendicular bisector will then be minus 1. Okay, so you sub everything into, again, the formula I wrote earlier on, y minus y1 equals to mx minus x1. Okay, this is your 3 over 2, and this is your 3 over 2, and this is your minus 1. And you end up with this equation. Okay, and if you call this equation 2, then you can substitute 2 into 1, okay, just like what you see in your notes here, to end up with this quadratic equation, which you can solve, okay, very quickly using your b squared minus 4ac formula to get 3 plus 2 root 2 and 3 minus 2 root 2. And those will be your x values for the 2 points A and B here. Okay, A and B. And once you know the x values, you can sub it back into your any of the two equations. I think this is the easier one to find your y value. Okay, so once you know a y value, you know the coordinates that you need. See, when x is there, 3 plus 2 root 2, y is minus 2 root 2, and you get the other pair of points. Okay, and giving you, remember your answer must be a complex number, giving you your x plus iy as your answer. Done. Now let's take a look at a second method to solve this question. Now the hence method, or the method that uses geometrical results of your diagram, is quite often the shorter and the more efficient way to get your answer. Now in this question, we want to find the points of intersection between the two loci. And if I let my x1, y1 represent the point A and x2, y2 represent the point B, then I can do this. I can first of all draw a right angle triangle here. Okay, I can from x2, y2 draw a dotted line down, perpendicular line down, and then because the gradient of this line is minus 1, I can write down the angle to be pi over 4. Okay, now writing it down as pi over 4, it gives me something. Okay, it gives me, let's say I call the opposite S and the adjacent T. Okay, now the hypotenuse is 4 because the radius of the circle is 4. I can write down straight away what S is and T is. Okay, sine pi over 4 is opposite over hypotenuse. So I can bring the 4 over. Okay, 4 sine pi over 4. Sine pi over 4 is 1 over root 2, giving me 2 root 2. Okay, now it's also equals to T. Alright, because tangent pi over 4 is 1. So opposite over adjacent is 1. T and S are the same. Okay, let me write that down. Tangent pi over 4 is opposite over adjacent. Okay, but tangent pi over 4 is 1. So that means my S is equals to T. Okay. Now if you don't want to use tangent, you can also use cosine, and then you end up with the same thing. Now once I know my s and my t here, then straight away I can write down what is my x1, okay, and my x2. Why? Because look at the diagram. Look at the diagram. Now this is the point 3, and if I look at this point, my x2 is actually 3 plus t, and my x1 is actually 3 minus t, because this triangle here is identical to the one that we were looking at earlier. Okay, so once I know x1 and x2, then I can work out what y1 and y2 are. Okay, done. In the end, I get the same result as the first method. It's shorter and more efficient, but you really have to look carefully at your diagram. Okay? Now if you're still wondering how to get y1 and y2, then you have to again look at this point. This point is 3, 0. Okay? And in particular, this is your s, and this is the s here. So your y2, for example, is just minus s, and your y1 is just s. Okay? Giving you the same pair of complex numbers as in method 1. Done. Now sometimes you may be asked to derive some geometrical result from the loci that you have drawn. Now in example 38, you are asked to first of all draw the loci given by part 1. Okay, this mod z minus 3 equals to 4. Now this is a circle centered at the point 3, 0 with radius 4. Then you're asked to sketch this second locus, mod z minus 3i equals to mod z. Now this is a perpendicular bisector, okay, of the points 3, 3 and the origin. Alright, then they want you to find the exact values of all complex numbers that satisfy both loci. So actually all you need to do is to look at the diagram and look for the point of intersection between the two loci. Now in your notes, the diagram has been drawn for you. Okay, you see the circle mod z minus 3 equals to 4, okay, which is this one, okay, and then you see the perpendicular bisector, okay, of the point 3, 3 and 0, okay, drawn very nicely for you over here. Now they want you to find the z that will satisfy both loci. Okay, effectively that's just asking you to find this point and this point, which we have called A and B, the point of intersection between the two loci. Now there are two ways to find A and B. Now the first way is to just use simultaneous equation and solve, meaning, okay, let's move down, meaning you write down the equation of the circle in terms of its Cartesian variables. Your z minus 3 equals to 4, as I said earlier, is a circle with center 3, 0 and radius 4. So that gives you this equation. Okay, and then you can simplify it to equation 1 here. Now the second equation, okay, is a straight line. It's a perpendicular bisector of these 2 points, 3, 3 and the origin 0, 0. Now if you go back to the diagram, okay, how do you find this straight line?